Chapter 10 works with sums and differences of functions. So what I'm going to do first is give you an idea of what we're looking at. I like this section, but it's kind of confusing to a lot. So we're going to start like this. F of x equals x minus 2. So I'm going to graph that. 0, 2, come down to here. This would be 2 and 0, whatever. Okay, so in grade 10 when we started to learn about graphing and functions, one of the things that we learned was, what do I do when I have f of 3? What does that actually mean?
Oh, you're right. How you supposed to?
No. No.
X is replaced by 3.
Okay, so x is replaced by 3. So in other words, what I'm saying is, when x is 3, what is y? Agreed? Okay, so what do? Wherever I have x, I replace it with 3, and then I simplify this, so my coordinate would be 3 and 1, right? And so that coordinate would be right there.
Oh, so your y is your 3 too.
Right?
The y. Never mind, never
Why
mind.
is he 1?
Oh, never mind, sorry. Your
You good?
Yeah.
Okay, so we have to get this part down. I mean, this is important to us because we're about to get a little more technical, and we're going to actually do this with functions and functions. So, next order of business is this. F of x equals, sorry, I'll just keep it simple here for now. X minus 2. G of x is equal to 2x plus 4, let's say. Okay? And what I want to do right now is I want to do this. I want to know what f of g of x means. I want to know what it is. Okay. So, in the last one that I did here, I took whatever was in the brackets here, and what did I do? I substituted in for my x value, right? Now I'm going to do the same thing here. So it's going to look like this now. Instead of x, I'm going to have g of x. Subtract 2. Well, what is my g of x? Now this isn't arbitrary, this is a useless statement. I don't do this normally, but I'm just showing you how I get to this. So what is g of x? Well, I said g of x was 2x plus 4, right? So in other words, I should have actually just substituted in 2x plus 4 in for my x value there. And then I simplify it, and I come out with a new equation and graph. So what this says is I've got g of x, and where I have g of x, I put it in for x in that equation, and then I simplify it. So far so good? Okay, so what happens if I want to go g of f of x? What do you think I do here? So I take my equation of g of x, right? 2, and wherever I have x there, I put in x subtract 2. Oops. It's 4. So I substitute in my f of x equation for this, right? So now I simplify, I get 2x minus 4 add 4. My new graph is, or function is, equal to 2x. So far, are you following this? This is huge that we get this really understood.
How come? Like, I get that you put the f of x in the brackets, x subtract 2, but why did you put the 2 in again? Just so it can be the g of x as well?
I don't know your question.
Like, you have the x subtract 2 plus 4, because
Yeah.
x subtract 2 is
Because
f
that's
of
where
x.
x is right here. Here's my g of x equation, Lexi.
Yeah,
My g of x equation is 2x plus 4.
yeah.
So I got to take this and substitute it in there for x.
Oh. I see.
So it becomes 2 times, instead of x, it's x subtract 2. And into there.
So then when you would have done the f and then g of x, shouldn't you have substituted f of x subtract 2 into there somewhere?
No, this is my equation, x subtract 2. This is x subtract 2. But I'm putting g of x in there for it. Right on, we already lost you.
Yeah.
Let's see. Anybody else lost? Out of curiosity? Let's do this again. Let's change this up so it doesn't look so similar. F of x is equal to x squared. G of x is equal to x minus 2. Okay? Now I want f of g of x. So that means wherever I have x squared, wherever I have an x, I'm going to put in x subtract 2. So what does this become? X subtract 2 squared. Follow that? You sure? Go.
2x.
What's this telling me to do?
I have to put the x squared into the g of x.
For x.
Oh, okay.
So what's it going to say? What is the equation
4
for...
and then x subtract 2.
Pardon me?
I don't know.
You take this and put it in for that x right there.
X squared subtract 2. Okay.
You follow?
Mm-hmm.
You sure? Because it's going to get so much harder than this. I need you to know you can do this.
Yeah, I think I can.
What is that going to look like?
X squared subtract x subtract 6 subtract 2.
No.
Or no?
X take away 2 squared, take away x, take away 2, take away 6.
Yes. Take this and put it into that equation. All right?
Yeah, that's backwards.
Would be x and then
Right? So basically, sorry, maybe I'll do this different. Hold on. Let me do one more step and maybe this makes more sense. What is f of x? Well, f of x is x subtract 2, right? So that means then that I want g of x subtract 2 now. Is what I want. Right? Because that's what f of x is. Agreed? So instead of writing f of x, I'm going to put x subtract 2 there. Now, x minus 2 squared minus x minus 2 minus 6. Just like Jeffrey said. Is that better?
Yeah, that
Yeah.
makes sense.
That makes sense.
Okay? That's what I should have done to begin with. Sorry. Okay? That makes more sense now? Okay, so now, if I do this the other way, alright, now I want f of, so I write that out, f of x squared minus x minus 6,
Minus 2.
and that has to go, yeah. So that goes into the equation, x squared minus x minus 6 minus 2, which is into there.
That makes sense.
Does that make more sense for everybody now?
Yeah.
Yes or no? I need consensus here because I gotta move on. Are we okay? Okay, so this is what we call composition of functions. So this is what we begin with. All right, so let's look at our example. Now, we have to get into what the domain and range looks like. So there's a couple rules for that, but for right now we just need to get down this part of how do we do this and what does it look like. All right, consider the following. F of x equals x plus 1 and g of x equals 2x subtract 5. determine the equation h of x. So h of x is when I take the f of x function and I add it to the g of x function. So basically what it's saying is this, f of x plus g of x. What's my equation for f of x?
X plus 1.
And what's my equation for g of x? Subtract 5?
Yeah.
Thank you. And now I simplify it. There's what h of x is equal to when I add those together. Okay? So I'm taking two separate graphs and I'm combining them together by adding them to create a third graph. Okay? So far so good. I want to show you this on here. Let's open it. Okay. So the first graph that I have was y equals what? Sorry. What was the first graph?
X plus 1.
X plus 1. So it equals that. What was the second graph? Y equals
2x subtract 5.
2x subtract 5. Enter. Okay, so I have these two graphs right here. Let me try and center this a little bit better for us. Everybody can see that all right? Okay. What I want to do then is if I'm adding f of x with g of x, I take all of the y values of f of x and I add them to all the y values of the g of x. So let's start with the most obvious one here. They both go through x equaling 6, right? So that is 6 and 7. Agreed? That's the coordinate for both of them. So the coordinate on my new graph then would be 6 and
14.
14. I add my y's together. So far so good. So that would be my new one, okay? Let's take this one right here. That is 3 and 4. And this guy right here is 3 and 1. So my new coordinate would be 3 and 5, which would be right here when I add them together. You follow what I'm doing here so far?
Yeah.
So I should list out all my x's and y's and then just show you how to add them together. But I think you can follow this so far, right? Okay, so now I'm just going to change my grid a bit here. Okay, so that's what I have right here, okay? So now, I need to add those two together. So I'm just going to simply add, what was the first equation?
X plus 1.
X plus 1. So this new line, whoops, this new line should go through 3 and 5, and 6 and 14, right? Does it go through 3 and 5? Right there. Yep. Does it go through 6 and 14? Right there. Yeah. Okay. So what I'm doing is I'm adding two separate graphs together by adding all their y values together to create a third graph, which is this guy right here. So this is the equation of the third graph. Y equals 3x subtract 4. Does it make sense so far?
Yeah.
Okay. Sketch the graphs. Done that. State the domain and range of h of x. So what's the domain and range of this guy?
You just both of them are all reals.
Yeah. Right? It's a line. So it's a graph of a line. So it's an element of all reals, right? It says determine the values of f of x, g of x, h of x when x is equal to negative 3. Okay, so if x is negative 3, what is f of negative 3? F is negative 3. F of negative 3, what does that equal? Negative 2. How about g of negative 3? What does that equal? Negative 11. So when I add negative 2 and negative 11, what do I get? Negative 2 and negative 11 makes? Negative 13. What's 3 times negative 3? Negative 9. Negative 9 add negative 4 is? Negative 13. Gives me the same answer. If you look on page 327, they show you how to draw those out like that. Okay? All right. Any concerns about this so far? The next step is to show you how to subtract 2. So what do you think the difference is then when I'm subtracting 2?
It's just your f of x subtract.
Look at the camera. Somebody's going to have seizures watching this video.
I got it.
Okay? What did you say?
It's just your f of x subtract g of x.
Yeah. Okay, so I go, all right, what's the equation on the top of that page? F of x is equal to x squared, right? G of x is equal to
4x subtract 4.
4x subtract 4, thank you. And it wants us to find h of x, which is f minus g of x, like that. So what does that say? I take f of x and I minus my g of x. So far so good. So that is x squared minus that, which is going to give me 4x plus 4. We all can follow that? We understand that? Okay? Excuse me. So when I subtract these two, I have to change the signs on both. So, from this graph minus that graph, I get a third graph that looks like this. Okay? Alright. Clear these graphs off. Delete all graphs. Okay. First graph is y equals x squared. Alright, the only thing I want you to make note of right now. What is the range for this graph? Y is greater than or equal to 0. Agreed? Write that down just in the margin somewhere. Y is greater than or equal to 0. Okay? Alright. The second graph is 4x minus 4. So that's what it looks like. Just like that, okay? And what's the range for this graph? Y is an element of all reals. Okay, so far so good. Alright, now I need to subtract these two graphs. Again, I'm subtracting y values. Actually, I don't know if I can do this. Hold on. Let me see if I can pull this up for you. White tables. Beautiful. Love it. Here we go. Okay. Y equals x squared. There's your values of your y. Here's your values of your x. Or sorry, of your y of your line. Agreed? We're okay? Does everybody follow what's happening here? So these are your x's. This is your y for your parabola. This is your y for your line. Okay. 64 subtract negative 36. What is it? 100. 49 subtract negative 32. 81. Let's go a little bit easier. 4 subtract negative 12. Yeah. 1 subtract negative 8. 9. 0 subtract negative 4. Doing good so far. Doing well. 4 subtract 4? 0. So you follow what I'm doing here. I'm just taking the y's of the first graph, subtracting the y's of the second graph, okay? But when I did it algebraically, I came up with this as my new graph. X squared minus 4x plus 4. You following so far? So, if that's the case then, I go into here, I go x squared minus 4 plus. That was my graph, right? So these values right here will be all of these values when I subtracted them. All right? There's what it is. Is that what I got? Yes. Now, what do you notice about the range of the third graph? What is it?
It's the same as f(x).
Okay, so the rule is this. Flip back to page 325. This is the best part about it. You don't need to remember anything. The range for the graph is solely determined on whatever that third graph is. So you just look at the graph and then get your range. You don't have to remember anything. Doesn't matter what the first is, doesn't matter what the second is. When you subtract those two or add those two, okay, you just draw the third graph and find the range of it. That's it. It's easy.
So are we allowed a calculator for this thing?
Not yes and no. You will be for a little bit, but eventually it gets into a part where you don't need the calculator. Okay? But for right now, for today, yeah, you'll use Desmos just to check them all. Okay? Now, I need you just to look at that same page. The domain, though. The domain for this. What's the domain for y equals x squared? All element of all reals. The domain for the line? Element of all reals. Therefore, you take only what's common. Okay? So basically what that means is you take the domain for the smallest graph you have. Okay? Does that make sense? So the smallest graph you have, like in this case, they're both all real numbers, right? But what happens if I had a square root graph and a quadratic graph? I'll show you that in a second. But the domain is always of the smaller amount. Okay? So in this case, they say the domain is the combined function. But you know what? In all reality, the domain is going to be whatever the domain is for your new graph. As long as you can graph the third graph, you'll get the domain and range from it. And that's the essential part of this chapter 10. Are we okay so far? There's a lot to take in right now. So the hard part, where does the hard part end up here? Take a look at 328. Alright. Use the graph of f of x and g of x to graph h of x equals f plus g of x. Okay. Two ways to approach this. Number one is write out your table of values like they did there in the first method. Write down your y coordinates for f of x. Write down your x coordinates for g of x. And then add them together. Are we following that? So, on f of x, you see where f of x is? Negative 8 and what? Let's fill in this chart quickly. Negative 8 and what? Negative 3. Negative 4 and? 0. 0 and? 3. 4 and? 6. 8 and? 9. Right. Okay, great. How about g of x? Negative 8 and?
1.
1, negative 4 and 0, 0 and
One.
negative 1, 4 and
Negative
negative 2, 8 and
three.
negative 3. Okay. So we want to add those together. So write down what the addition of those, the sum of those coordinates are, the sum of the y's. So add the y's together. What do you get?
Negative 2, 0, 2, 4, 6.
Negative 2, 0, 2, 4, 6. Agreed?
Yeah.
Everybody's okay with that? So now I can graph those coordinates, draw your line through it, done. There's what h of x equals. Okay? Good so far? Okay? The second way to do that is find the equation of each of the lines. So, y equals mx plus b. F of x equals. What's the y-intercept for f of x? What is it? 3. What's the slope of that line? What is it? 3 over 4? Okay. Good. G of x. What's the y-intercept?
Negative 1.
Negative 1. What's the slope of that one?
1 over 4, negative 1 over 4.
Negative 1 over 4. You guys agree with that? Okay, so I'm going to add those together now. I'm going to add those together. So h of x equals 3/4 x plus 3 add negative 1/4 x subtract 1. What does that give me? 2/4, so 1/2 x plus 2. Is 0 and negative 2, was that one of my coordinates? Or 0 and plus 2, sorry? Was 0 and plus 2 one of my coordinates for h of x?
Yeah, it was.
Yeah, it was? Awesome. Is the slope on h of x 1 over 2?
Yeah.
Done. You can check your answer with it too, if you needed to.
Then we just graph that part.
Sorry?
So then we just graph it.
Yes.
Okay.
Yes. Okay? I'm not going to do the products and quotients, too much. Tuesday we'll do products and quotients.
Do we have to graph the parabola, like the quadratic equations? Do we have to do that at all?
Yeah. But likely some of it will be technology that'll help you.
Okay.
Okay? But yes, you won't have to like complete the square or do any of that stuff. Just use your technology for now. Okay, so 10-1. That's it. Alright? 40 minutes to 45 minutes to do that.
Can I go to the washroom?
Can you?
You said may I?
You certainly may.
Punch it?